The broadcast is now starting. All attendees are in listen-only mode.
Okay, so it's 3:15. We're gonna get ready to get started. My name is Michael Poles. I'm the Regional Electrical Products Specialist for the Northeast region. I know some of you are probably looking to get Mark Arnold, our National Project Manager, hear from him, but fortunately for myself, I get to be the center of attention today. So we're gonna cover SMC sensors with the pressure, vacuum, and flow. Essentially, what we're going to highlight a little bit today is how pressure, vacuum, and flow switches and sensors will provide insight into machine operation and the health of the machine and the process. So basically, it's to know when equipment is degrading and at what point it needs to be addressed to reduce defects and saves on costly unscheduled maintenance when you use the right tools for what SMC can provide. So we've only got about 15 minutes, so I'll kind of step into it, and we'll leave hopefully a little bit of room at the end for some questions. If you do have questions, feel free to put them in the chat. If we do not address your questions during this session, we will follow up with you after the fact, so don't be shy. Or if you have any other questions, definitely follow up with your SMC representatives, and we can get in touch with you and address whatever concerns you may have or questions you may have, if it is unique to an application or just a general question overall. So, brief background, SMC is continually incorporating new pressure switches, flow switches, and monitors in our sensor series. Our sensor solutions are designed to gather and provide the information the customer really needs in a very easy way. With our sensors, they will know at all times what is happening within their machines, and they will be able to make decisions that will allow them to increase productivity, efficiency in their processes. So here's a synopsis or snapshot of some of our product lines. We have our ISE or ZSE sensors, which relate to pressure, compound pressure or vacuum. And we also have our PF flow sensors, which are essentially for air and liquid flow. A lot of these have been redesigned recently in the past couple of years to improve the ease of use for the units as well. So what applications are good for pressure sensors? Where can you implement them into your processes, and what can we do to help you out? Well, essentially, they're very popular for general packaging machinery, monitoring mainline pneumatic pressure or specific process pressure, doing something very unique in your system. It's also used often for vacuum systems to monitor the vacuum pressure and confirming workpiece detection or holding. Other pressure sensors are used for fluid, so non-food contact, pressure monitoring, things along that nature. Also, we have some high pressure process systems, such as blow molding pressure confirmation to make sure that everything is running as expected. So some applications for these pressure sensors we're going to get into in the next few slides. On the left, we're looking at a confirmation of supply pressure in the airline itself. So the ISE 35 series is more of an integrated component where the line pressure can be adjusted and then monitor with a digital readout. This provides a visual verification of the operating pressure at that point. The output can be programmed to respond to supply pressure drops, etc. So if there is something that if there is a supply pressure drop, you can get feedback through digital inputs, is what that's referring to as an output within the unit. We can also use some of our remote sensors, which we're looking at on the right, paired with a monitor. That would be this PSE 560 and PSE 300A series combo. The 560 is a remote type, and then the PSE 300A is the monitor that we're looking at. So in this implementation, you can see a little diagram where it's showing that the supply pressure of water, oil, or whatever fluid may be can be confirmed by using a sensor for those gases or fluids. So some other applications for pressure sensors or unique implementations is on the left, we're looking at our ZSE 20 CF. So the ZSE 20 series, this is used in this application for suction of a stainless diaphragm. It enables us to detect even though water or oil is adhered to that workpiece, and it can make ingress into the sensing part. On the right, we're looking at a leak test verification, essentially a combination of the PSE 532 series with the PSE 300A, which is the monitor we were just looking at before. The PSE 532 is a low pressure sensor, and it's used to detect very minute differences. The auto shift function, which is one of the many functions that we have within some of our monitors, reduces the influence of fluctuations in the supply pressure to allow for a greater sensing capability and control. Some other applications for pressure sensors which are pretty unique, we have on the left, we're monitoring for filter clogging. So whether it would be an airflow application with the filter, the PSE 550 is more of a differential type. So it senses the filtration and placement periods can be controlled, monitoring to see if there's any clogging of the filter with this type of differential pressure sensor. Another implementation which is fairly unique is for liquid level detection. It can detect a level of liquid through changes in the purge pressure in the line as well. So that one's a little more unique with the PSE 550 series as well. So other applications for flow sensors, we were looking at a lot of pressure sensors previously. Now we're going to roll into some flow sensors. So the flow, where can we look at flow? Well, for general packaging machinery, we can monitor mainline pneumatic flow, and we can trend consumption and identify abnormal conditions such as leaks in certain cylinders or whatever it may be. For monitoring the flow rate and total flow of purge gas, such as nitrogen, we can use this for container leak detection. We can use this for air blow system consumption monitoring, or also chilled water flow. You can check that loop and the temperature confirmation that goes with it as well. So we do have a multitude of sensors for flow, which are very beneficial as well. So some of the applications for flow sensors, on the left, we're looking at the PF2M series. This is used in some nitrogen applications. So it's looking at the accumulated indication showing the flow rate or residual amount of nitrogen, etc., left in a gas cylinder. So pretty unique. I've seen a few applications with that. Also on the right-hand side, what we're looking at is the control of purge airflow being used in an ionizer, where you can use this to really optimize and fine-tune the flow in your system. It could be an energy savings application as well to really allow you what's going on, allow you to know what's going on. Some other applications that are popular with our flow sensors are early leak test detection. We have that with our PFMV series. Here we can see it's detecting pinholes in molded parts. On the right-hand side, we're looking at the PF3W-Z series, and this is what we were talking about, looking at chiller flow or coolant flow and temperature, and that's what this is looking at. It's monitoring the flow control and circulating of a fluid in a chiller. So another slide that we have here really is a little wordy in a way, but IO link in sensors is really booming in the industry now. So we have a lot of IO link and sensors that are a natural part of the IIoT or Industrial 4.0, Industrial Internet of Things that's coming into the industry right now. So machine condition monitoring is becoming more and more important for the overall equipment effectiveness, or OEE is the industry acronym. So not only is the machine health monitored, but even the sensor health itself. IO-Link enables an automatic configuration or parameter data for replacement sensors. So what that means is a lot of the settings and hysteresis values and initial setup information that you would have if you're replacing a sensor, this can push automatically down to the units. You don't have to reprogram replacement sensors. Also very popular if you're doing subsequent builds of the same type of application, so it works the same way. IO-Link replaces analog signals with digital signals over a serial communication line. This improves a lot of resistance to noise, and it really lowers the cable cost. It also lowers your IO point count if you are tying this back into a PLC. So with IO-Link, it's probably one of the most and fastest growing protocols for Industry 4.0. And SMC has made a very large, should I say, leap into this industry where we've upgraded a lot of our sensors to include this IO-Link capability. So at this point, we've got a few minutes left. I will see if we have anything in the chat. Doesn't appear that we have any questions at this point. If there are any questions, please don't hesitate to let me know. If you do have any interest in what SMC can do for you, enrolling into and checking out a lot of our sensors, we do have local and regional sales reps and application specialists and staff like myself, which are more technical specialists. We can really narrow down what you're looking at and provide a solution for you to really optimize the use of our sensors and what SMC can do for you. Let me see if we have anything. We'll just okay. So definitely feel free if we don't have anything in the chat, we'll get ready to wrap up. You can also use the chat function or send an email in our PAC Expo virtual showroom, and we can reach out to you there at that point if you have any specific questions for a unique implementation of your machines or applications. We'd be happy to discuss it with you and come up with a solution that SMC can provide to really optimize what we can do for you. So we'll just leave it open for another minute or two until we hit our 2:30 mark. And if there is any other questions that may come up, I'd be happy to address them. And again, definitely don't hesitate to reach out to your SMC reps or in the virtual booth and discuss anything that's unique and specific as well. So at this point, we're about wrapped up. I just want to leave it open if anybody had any last minute questions. If there is anything, definitely don't hesitate to reach out. Thanks for your time today, and following through with a brief introduction that we can provide in 15 minutes on SMC's sensor line and what we can do for you. So again, thank you very much, and I think that would about do it.